Hello, welcome everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. This is the lecture number 23 and it is the continuation part of the graph topic, and from the unit 3 the lecture for course is Bachelor in Pharmacy and the subject is Biostatistics and Research Methodology and the code is 801T, Dr. APJ Abdul Kalam Technical University, Lucknow. The content of this lecture are cubic graph, response surface plot and contour plot graph. The cubic graph. What is cubic graph? A cubic graph is a graphical representation of a cubical function, and a cubic is a polynomial which has an x raised to power 3 terms as the highest power of x. So, cubic graph is a graphical representation of cubical function and which has a polynomial and having the highest power of x cube. Cubic graph have two turning points, a minimum point and a maximum point. This is a graph of y equal to x cube. If you see here, when y equal to, for example, if x equal to 1, then the value of y equal to 1 cube, that is 1. So, the first point, the coordinate for this is 1 1. So, when this is the x axis and this is the y axis, and if x equal to 1, y equal to 1. So, we get the coordinate this 1 1, and if x equal to 2, then y will be equal to 2 cube, that is 8. So, the second coordinate is 1 8 and it will be here, sorry 2 8, this will be here. So, this is the point 2 8. So, if we join and when x equal to 0, y also 0. So, this is the origin. So, if we join these points, we get this curve, and in the similar manner, if we have negative values of x, that is x equal to minus 1, then y equal to minus 1 cube, that is minus 1. So, the another coordinate is minus 1 minus 1. So, this is point here, this is minus 1 and minus 1, and if we have x equal to minus 2, then y will equal to minus 2 cube and it will be minus 8. So, the another coordinate for this is minus 2 and minus 8, and the point is minus 2 and minus 8. So, this is the point minus 2 and minus 8. So, if we join from origin to this point, we get this curve. So, this is the cubical graph as it contain y equal to x cube and x has power 3. In another graph below, the coefficient of x cube term is positive. So, the graph is increases and the equation for this is y equal to x cube, y equal to x cube minus 2 x square minus x plus 2. So, this is x cube, sorry, x cube minus 2 x square minus x plus 2. So, if we put the different values of x For example, if we put here x equal to 0, then y equal to 0 cube minus 2 into 0 square minus 0 plus 2. So, it will be equal to 2. So, the 2. So, we say here when x equal to 0, the y equal to 2. So, the intercept of y is plus 2 in this graph, and if we put here x equal to 1, then y will be equal to 1 cube 2 into 1 cube minus 1 cube 2 into 1 square minus 1 plus 2. So, 1 minus 2 minus 1 plus 2, and it will be equal to 0. So, this the coordinate for this is 1 0, and 1 0 is point is here, and when x equal to 0, y equal to 2. So, this is the point for, and when x equal to minus 1, y equal to minus 1 cube 2 into minus 1 square minus plus 1 and 2. So, this is 1 minus 2 plus 1 plus 2. This is minus 1. So, this point is so when x equal to minus 1, y equal to 2. So, this is the we get the point, and so on we find all the points. Minus 1 cube minus 1, 2 into minus 1 square, that is minus 2, then minus 1 we put here, it will becomes plus 1 and plus 2. So, this is 0. So, when this is for y value minus 1 and 0, and when x equal to, again we find more than one value, we find the value of x 2 and so on, and we plot the graph. So, we say here at this point the curve changes the direction, and also this point the curve changes the direction. When the point where the curve changes its direction, this is called the vertex. This is called vertex. So, these are the vertex of this graph or this cubic plot. This is vertex and this is vertex, and the y intercept for this graph is plus 2, and if we put x equal to 2, then we find y equal to 2 cube minus 2 into 2 square minus 2 plus 2, and it will be equal to 0. So, the equation ends with the plus 2 for x equal to 0. In mathematical field of graph theory, a cubic graph is a graph in which all the vertices have degree 3. In other words, a cubic graph is a 3 regular graph. Cubic graph also called trivalent graph. So, if you see this is a graph cubic graph, and if you observe any point, it has 3 edges 1, 1, 2, 3. This point also have 1, 2, 3. So, you see here all vertices have degree 3. If you see this, it has this and this. If you see this, this vertices, it has also 3. So, all the vertices have degree 3. So, in mathematical field of graph theory, a cubic graph is a graph in which all vertices have degree 3. In other words, a cubic graph is a 3 regular graph. Cubic graph are also called trivalent graph. Now, second is response surface plot. Response surface plot such as contour and surface plot are useful for establishing desirable response values and operating conditions. Before going to learn response surface plot, first I explain you response surface methodology or simply RSM. Response surface methodology also known as response surface modeling, and it is a technique to optimize the responses or response when two or more quantitative factors are involved. The dependent variables are known as responses, and the independent variable or factors are preliminarily known as predictor variable in response surface methodology. The response surface plot use surface plot when you have stored model and want to plot how the fitted response relates to two continuous variable. A surface plot displays the 3-dimensional relationship in 2 dimensions. We remember a response surface plot displays the 3-dimensional relationship in 2 dimensions with the variable on the x axis and the y axis, and the response variables variable represented by the on z by a smooth surface. So, the independent variable or factor or explanatory variable are on x and y axis, and the response on z, and it represent by a smooth surface. So, response surface methodology generally is very useful to optimize variables, factors, or more particularly as compared to just the statistical significance test for a particular point. For example, point is estimate statistical region jargon, for example, to optimize humidity and temperature for the best comfort. So, in this example, humidity and temperature are independent variable and comfort is the response variable, and it is also dependent variable as comfort depends upon the humidity and temperature. The response surface is plotted on next slide. The human comfort is measured in this example on a scale between 0 to 10, where 10 is the most comfortable and 0 is the there is no comfort when the value is 0. Okay. So, the response surface plot is this, the response surface plot of comfort versus humidity and temperature. So, in this we see here, this is the x axis and the temperature is 60, 70, 80 and humidity is 0, 25, 50 and 75, and the comfort on z by surface this colored area, and this is the comfort, and we observe that the maximum comfort between the range, if you see here the maximum comfort from this surface, it is from approximately 60 to 78 or use 76 or 75, more than 75. So, for maximum comfort for temperature is more than 65. If we draw a line from this and this is the maximum comfort, and for the humidity we see here the maximum comfort for near than 50. So, we find the this is the response surface plot for comfort versus humidity and temperature. Another is term is contour plot. In contour plot, the response surface is viewed as two-dimensional plane, where all points that have the same response are connected to produce contour lines of constant response. So, in contour plot, response surface viewed as a two-dimensional plane and all the points those have same responses are connected to produce contour line. So, contour line formed by the points, those points which have same response and or you can say constant response. Contour plot, what are contour plot? Contour plots commonly called level plot. We also called these plots as level plots and are a way to show a three-dimensional surface on a two-dimensional plane. In contour dimensional plot, contour plot, we show a three-dimensional surface on a two-dimensional plane. It graphs two predicted variables x and y and the y axis and a response variable z. So, in this graph it different from the surface plot. In this we produce it in two-dimensional plane and this graph have two predictor variable x y on the y axis. Be remember the both predictor variable x and y are on y axis, while in surface plot the both predictor variable are on separate axis x and y. So, this is the difference between surface plot and contour plot and the response variable on z as a contour. These contours are sometimes called slices or iso response variable. These contour are sometimes called z slices or iso response values. This type of graph is widely used in cartography, where contour lines on a topological map indicate elevation that are the same. Many other disciplines use contour graph including astrology, meteorology and physics. Contour line commonly show altitude like height of a geographical features, but they can also be used to show density, brightness or electric potential. So, contour graph widely generally used in cartography and in contour plot, contour lines on topographical map indicate elevation that are the same. A contour plot is appropriate. We want to see how some values of response variable or dependent variable z changes as a function of two inputs x and y, where x and X and capital Y are the independent variable or factors, and it can be written as z equal to the function of x y, z equal to f of x y. So, it shows that how the value of response variable of z changes with the value of x and y with a relation or a function. So, a z changes as a function of two inputs x and y. While the response surface is visually appealing and provides a quick meaningful overview of the relationship, a contour plot is easier to understand with respect to the optimized value for the independent variables. for which the same level of comfort for that is response or dependent variable can be achieved. I again read this: while the response surface is visually appealing and provides a quick meaningful overview of the relationship, but a contour plot is easier to understand with the respect to the optimized value for the independent variable for which the same level of comfort. For example, the contour plot we will see next slide showed that statically the same level of comfort can be achieved for the same color region in the plot. For example, the middle dark overall region of the contour plot in figure 2 represents the comfort level 75 can be achieved for the temperature approximately 65 and 78 degrees Fahrenheit between 25 to 70% of the relative humidity. Similarly, the contour plot can be used to find the ranges of the temperature and humidity to the same level of comfort, that is response. So, this is the contour plot, comfort versus humidity and temperature, and if you see this is the dark when a dark blue color the comfort is less than 0.5, for this color the comfort is less than 0.05 minus, that is very poor comfort, and this is for this minus 5.0, sorry, this is 5.0 and this is 5.02 minus 2.5 and this region for minus 2.5 to 0 and this region for 0.02, 2.5, this now more comfort, and in this region the comfort is 2.5 to 5.0 and for this now the comfort is 5 to 7.5. So, as we measure in this example the comfort on 0 to 10 scale, and as the value is increases we get more comfort. So, and in this the dark region have maximum comfort and it has less than 7.5 values, when greater than 7.5 the comfort score. So, this if you see the dark region lies between 65 to approximately 78, and for humidity this dark region is approximately 25 to more than 70 or 75, it may be 75. So, this is a dark region where the comfort is maximum. So, we read contour plot like this, and the next is contour plot. The most common form is the rectangular common contour plot, which is as the same name suggests shape like rectangle. Rectangle contour plot showing a symmetrical surface with a central part. So, here is the maximum value in this contour plot. Another type of contour plot is polar contour plot, which are circular in nature, and this contour plot for the function r sin theta. So, this is the circular contour plot and it is called as polar contour plot. Next, third is ternary plot. The ternary are triangular and show a relationship between three explanatory variable and a response variable. Most commonly the third explanatory variable is height value for x, y, z value in the ternary plane. For example, in this we see here there are three terms: carbon dioxide, nitrogen and oxygen, and the height shows the temperature, and as the color changes from 0 to 100 degree Fahrenheit in this example. So, we can measure the temperature on the basis of these gases. So, this is a ternary plot and it is also called triangular, and it shows a relationship between 3 explanatory variables. Be remember, here we have 3 explanatory variables: carbon dioxide, nitrogen and oxygen in this example, and the height value for xyz value in tertiary space, and temperature is dependent variable and response variable in this. So, this is a ternary plot. So, we have read 3 types of contour plots. Now, first is contour plots, then contour plot type rectangular common contour plot, then polar contour plot and ternary contour plot. Thank you.